Circular motion, exercise question 26, from H.C. Verma. Watch this projectile motion carefully. A particle is launched at angle theta with speed u, tracing a parabolic path. Now, consider a point P on the ascending part of the trajectory, where the velocity makes an angle theta by 2 with the horizontal. The velocity vector v points at this angle. Gravity g acts straight downward. But only the component of g perpendicular to the velocity, that is g cos theta by 2, acts as centripetal acceleration. The dashed orange circle is the oscillating circle at this point, and radius r is the radius of curvature we need to find. The question asks, what is the radius of curvature of the parabola traced out by the projectile in the previous problem, at a point where the particle velocity makes an angle theta by 2 with the horizontal? Recall from question 25 that the particle is projected with speed u at an angle theta with the horizontal. The key concepts. The radius of curvature at any point on a trajectory is given by r equals v squared divided by a perpendicular, where a perpendicular is the component of acceleration perpendicular to the velocity. Now, the horizontal velocity remains constant throughout projectile motion, equal to u cos theta. At the point where velocity makes angle theta by 2 with the horizontal component of velocity is v cos theta by 2, which must equal u cos theta. Finally, the perpendicular component of gravity with respect to the velocity direction is g cos theta by 2. Let us solve this step by step. Step 1. Find the speed v at the point. The horizontal component of velocity is v cos theta by 2, and this equals u cos theta since horizontal velocity is constant. So v equals u cos theta divided by cos theta by 2. Step 2. The perpendicular component of acceleration. The angle between g and the velocity direction is 90 minus theta by 2 degrees. So the component of g perpendicular to velocity is g cos theta by 2. Step 3. Apply the radius of curvature formula. Radius r equals v squared divided by g cos theta by 2. Step 4. Substituting the expression for v, after simplification, we get r equals u squared cos squared theta divided by g cos cubed theta by 2. The answer. The radius of curvature at the point where velocity makes angle theta by 2 with the horizontal is radius r equals u squared cos squared theta divided by g cos cubed theta by 2. Exam tips. First, at any point on a projectile path, always use the formula r equals v squared over a perpendicular. Resolve g into components parallel and perpendicular to the velocity. Only the perpendicular component provides centripetal acceleration. Second, the horizontal velocity u cos theta remains constant throughout the motion. Use it to find speed at any angle. If velocity makes angle alpha with horizontal, then v equals u cos theta divided by cos alpha. Third, remember the special cases. At the highest point, radius r is u squared cos squared theta over g. At the launch point, r is u squared over g cos theta. And at any angle alpha, r equals u squared cos squared theta over g cos cubed alpha. This is the general formula. Like and subscribe for more circular motion solutions at MAGPIEHUB.